Yeah,
Can you see the screen? Okay.
we can see them.
Let me put it into presentation mode and see if you can still see it.
Still works.
Okay, cool.
Let's see who we have. Maybe we can wait another couple of minutes before starting. Fatai, are you there? Okay, we can read you. Oh, Dhruv, you have 2 dots, not one. Congratulations. Okay, I think we can start. Let me see what is missing from the usual suspects. Sergio Gabrieli, Victor Schufeng. I think boarding is almost completed. We can start. So welcome everyone. This is an interim meeting of the CCAMP working group. Actually, today we have a very short agenda. The plan is to discuss the OTN network slicing draft, the framework and data model for OTN network slicing. This is a draft that was recently adopted by the working group with quite many comments. Uh, you will see in a few minutes during the presentation. Most of them have been collected and will be discussed by the authors that did a great job putting together these slides. You will find them very useful for our discussion. So the idea now, the draft was adopted because there is a clear interest from the working group in the topic. We will now see if and what changes will be needed. The idea is to have around 20 minutes of presentation and leave the rest of the meeting for open discussion. Is there anyone which would like to bring up some topic? I don't know. Ask for some time to be allocated for I don't know, a second presentation, etc. Or we are fine to start. We asked if there was anyone willing to give, let me say, an alternative presentation, but we didn't receive any request. This is a sort of a last call. I don't see any objection nor comments, so I think we can start. The stage is yours.
Okay, so let me put this into presentation mode. So first of all, thank you, chairs. Thank you for all the participants to join the discussion. So we, the authors, over the past few weeks have discussed about the comments and feedbacks also with the question raisers as well, and we put together like some slides to share our thoughts here. So here I'm presenting this draft, these slides on behalf of all the authors and co-authors. First, a few updates to the draft. So we since the draft has been working group adopted, and we have published this draft as revision 00 on the working group. And also we have migrated the GitHub repository to CCAMP, and with all the issues being tracked in that GitHub. We have discussed the comments through the mailing list, weekly meeting, and also a lot of offline calls. So here is a list of all the questions we received during the working group adoption call, which are being tracked in GitHub. Out of those comments, we have tried to categorize them into 4 parts. The first part is about more or less about the improvements to the draft text. And here we have noted down, and the authors are working towards a second update to incorporate those comments. And then for those comments that we have kind of reached a consensus during the adoption call, is to first we need to harmonize with the network slice MBI Yang in TEAS, and the consensus is the OTN slicing model will augment IETF network slicing Yang moving forward. And there's also another comment to ask the authors to harmonize this draft with the ACTN applicability, for TEAS applicability of using ACTN for slicing. And we have discussed with the authors, and there are some pictures in the ACTN slicing Yang that needs to be kind of clarified or updated to reflect our thoughts, so we could match what we are discussing with network slicing as well as OTN slicing with the picture defined in the ACTN slicing draft. And there are also a lot of questions during the discussion, which we believe could be addressable by TEAS. So for example, like slice is a conflated term, and some believes that slicing should be replaced with resource partitioning or something else. And also there are questions about why not just using existing models, for example, T topology, or the VM model for configuring network slices. And it seems to some that the current IETF network slice framework is just a little premature. So we probably should wait until it becomes clear to move forward with the network slicing work, as well as OTN slicing, for example. So those questions can probably be addressed towards TEAS. And so what's left is of I think 5 questions that are really related to this draft. And we're gonna see to put some responses towards those main points. So what those questions really boils down towards are 2 main points. First is, do we really need slicing for OTN, right? Because some believes that slicing should stop at the IP layer. Second is, can we call it a slicing for OTN, right? So So the next slide is about, first question is, do we need slicing for OTN? From the author's point of view, short answer is yes. So for the very first important reason is we have use cases for slicing in both networks that are OTN only, which means there's no IP, but end-to-end OTN, right? And there are also networks with IP over optical, for example, and so all the use cases, I mean, not all the use cases, but most of the use cases related to network slicing are described in this draft. But also, you could see similar use cases where are described in the IETF network slicing framework. For example, network co-sharing, co-construction, the wholesaling, the use of slicing to support private OTN interconnects, and also to support end-to-end network slicing using OTN as part of the constructor for the slicing. Besides the use cases, we also have, as a fact, we have many optical vendors who have already either deployed or commercial applications available that much resembles an OTN slice. But they are built more or less with proprietary interfaces. And this is also one of the very reasons that implies a standardization of such an interface for slicing is necessary in order to achieve interoperability, right? And this is why we are pushing the model here in IETF. And also, the slicing for OTN is in the scope defined with the IETF network slice framework, as we put the quote here. So just to not go through this in detail. Okay, so over the discussion, I think that one of the main points people have different thoughts is around what is intent and what is realization, right? From our point of view, an intent is to express what a customer needs from a high-level perspective. So in that case, a network slice can be expressed as a network topology or a set of connections with measurable SLOs and SLEs, right? So in that sense, when we call it an OTN slice, that slice is an intent. On the other hand, when we have a realization, it means how a slice is actually realized in the network. And as far as IETF considers, there are already many IETF technologies available for the realization of a slice, and also on the OTN layer in the control and management plane. Right? For example, all the points about L1 VPN, T topology, T tunnels could be used to realize a slice. And also, people could even use NMS or direct netconf in YANG to configure the cross connects with that supports an OTN slice. So all those are really how it can be realized. And at the data plane, because of the nature of OTN data plane, it will always be time slot based, and what we can call it hard slicing at the data plane. Right? So today we are short of an intent-based MBI model, which can be used at the northbound of the controller to support OTN slicing within the scope of the IETF network slice framework. For the realization part, the slicing for OTN is actually, as we have as argued, is relatively simpler to realize at the data plane because of the nature of OTN. But that does not mean that we do not need the concept of slicing, right? For example, we still have to consider what is an OTN technology-specific SLOs. And a slice could carry certain SLOs expressed as a matter of OTN signal quality at the endpoints or at the path level. Examples of the SLOs could be expressed as a bit error rate or a frame jitter that are relevant to OTN technologies. And also some of the generic SLOs, such as bandwidth and availability, would need to be reinterpreted at the ODU added ODU layer to match what OTN provides. Right? Okay. Oh, since I'm in full screen mode, I don't know if I should stop for questions. Maybe just feel free to let me know when this happens.
Okay. I'll interrupt you if I see any questions popping up.
Yeah.
Someone in the queue.
Okay. So we are trying to put this picture to basically say what are the scenarios we have seen for slice configuration in OTN networks. There are several cases, right? On the left side is what we see a typical use of for OTN slices in an OTN-only networks. And in this case, when we have OTN slice controller and an OTN slice aware consumer, which uses the OTN slice MBI to configure an OTN only slice, right? Whereas on the right side is an IP plus OTN. And there are also two options to create an OTN create a slice over IP plus OTN networks. In one case, on the right side, we could have an IETF network slice controller to provide an IETF network slice to its customer, and the IETF network slice controller can talk directly with IP and OTN over existing MBI to configure to realize actually the slice that goes across both IP and OTN, right, layer to layer. But on the other side, if we see the option in the middle where an IP and OTN could be peer-to-peer mapped under the IETF network slice controller, in which case the IETF network slice controller could delegate the part of the end-to-end slice within the OTN domain to the OTN network slice controller, right? And then it could form really an IETF network slice and give it to its customer on the top, right? In both of the cases in the middle and the right, the interface to the outside customer is always IETF network slice MBI, which is technology agnostic. When it comes to the OTN domain, then the technology-specific OTN slice MBI could be used or it could use any existing models to do the job, right? And for OTN slicing on the left side, then the technology-specific OTN slice MBI will be used to support an OTN-aware customer to configure an OTN slice. Okay.
I have a question on this slide. Do you prefer all the questions at the end, or we can take it now?
Yes.
Okay. So actually, I understand that the first use case, the TN only, where we need the OTNSC to let me say be a sort of gateway between the consumer and the network. So I understand why we need an OTNSC NBI over there, but in the picture in the middle, since the IETF NSC has an SPI that is capable to directly interact with the IP network, couldn't we have the same for the OTN network? In other words, yes, exactly, that one. Couldn't that be another NSC SBI? Because in the third picture, you give the impression to do what I'm asking, in the sense that there is a PNC NBI. If I understood that correctly, the IETF NSC in the third picture is capable to request the realization and no longer the intent of an OTN slice. So, for example, there it could be asking what we call the L1 VPN. My question is why can't it ask for the layer 1 VPN also in the picture in the middle?
Oh, for this picture, yes, you're right. So for the IETF network slice controller can directly use the PNC NBI to realize the slice in OTN, right? But it also has an option to delegate the piece of the slice configuration to the OTN slice controller with an intent-like interface. And the framework also points out that we could configure a slice either in a hierarchical way or stitch them together, right? So in that sense, when we have an OTN SCNBI, we allow both options to work. And as a matter of fact, you see this. So the use case on the left and use case in the middle for OTN, there's no difference. So it doesn't matter whether the request comes directly from OTN aware consumer or from the IETF network slice controller, right?
Yeah, but in one case, I mean, on the left, I understand the intent-based type of request because that comes from a consumer. But on the right, on the middle, in the middle, I don't understand why the IETF NSC needs to have something that is intent-based. That's just my concern. But I see the queue is populating. Probably, I mean, I leave room to the others for discussion. We have Igor at the beginning of the queue.
Oh, okay. So, guys, we do the discussion basically whether OTN slicing is needed or not. Okay, and my question is whether OTN slicing as a concept makes sense. In my opinion, it doesn't make sense, and here's why. Okay, the network slicing is inherently top-down process, emergent dynamic process. And the goal of the process is to create connectivity constructs of various types, of various complexity levels, which can support SLOs throughout the lifetime of the slice. That's the purpose of network slicing. Okay, so again, it's top to bottom emergent process. Okay. Now OTN is still the transport layer, and as such, it do what it always does. Basically, it can offer bottom-up network building process. Okay, basically by providing point-to-point links to higher clients. So, for example, imagine an application which needs point-to-multipoint distribution with certain SLOs, and it asks for a network slice. The IP slice, while realizing the necessary tree, of course, can make use of OTN, okay? But it doesn't do it in a literal way. It doesn't ask for OTN slicing. Basically, for example, it wouldn't try to map point-to-multipoint tree onto point-to-multipoint connection created in OTN, okay? What it will do, it will ask OTN, and not just one OTN, but probably multiple independent networks, multiple independent OTNs. And not just OTNs, by the way, it could be different other transports, probably even without OTN, but all the same, all it will ask is to create more links to enrich IP topology so that it can realize the point-to-multipoint connectivity. Okay, so it is basically, there is something novel that slicing were discussed in the network framework, but absolutely nothing new what we are trying to do in OTN. Okay, even when you have end-to-end OTN, at the end of the day, it is the end result is a end-to-end OTN service which provides a link to a higher client. Okay, this is one point. The other thing is that I asked many times about this question, where this other than point-to-point connectivity will come from, and they come and go away out of the question list. Okay, so I want this to be answered. And finally, the authors think that the network slicing framework is not limited to 5G. Okay, and I question this as well. So of course it's not limited in a way that other applications can use it, because there is no way to prevent from using that. But there is nothing in the NS framework, which is defined in the NS framework, which is not needed for 5G. There's nothing at all. And there is nothing that came from other application other than from G into NS framework. So in this sense, it is limited to 5G. In fact, it's all about 5G. It is it's a very old concept that existed for decades, and it only came to life because of a 5G. Okay, so again, from 5G point of view, ATN has no changes at all. Okay, so the coincidence why OTN slicing came exactly when people talk about slicing in terms of 5G, it's more than suspicious. Basically, it is something that artificially brought to life, in my opinion. Okay, so whatever we do in OTN, it's not slicing. That's what I'm saying. It's still transport. It's still bottom-up network building.
Should I answer Igor's call, or do we wait until the comments are in the queue?
As you prefer. As you prefer.
Okay, so let me try to respond first. So in terms of the comments that there's nothing new for OTN slicing, well, I mean, for we agree that there are a lot of technology that are currently available in IETF, right? So from the perspective of say realizing a sort of quote unquote a slice for OTN, there's nothing new because we have the data plane and we have control plane technologies, right? But that does not mean to say we do not need an intent-like interface to express what we need for a slice in OTN, right? That's the first comments. And the second question, I think, is about whether it's necessary to support P2P or P2MP and MP2MP kind of services. And actually, we have a slide on the next page. Let me try to bring this up. Right. So what do we understand is, so currently for OTN, right, point-to-point and point-to-multipoint connections are supported by the OTN data plane. The only suspect is about MP2MP, which is any-to-any, which is not supported by the OTN data plane. But from a service point of view, it is always an operator's choice if it should support slicing with point-to-point or point-to-multipoint services, right? And when operator provide an OTN slice service, not all possible service types need to be supported by an OTN slice. And the type of services, which and also the SLOs, are always negotiable between the consumer and the provider. So you could provide any service based on the capability of your network. And I think there's another comment about whether it's necessary for OTN to support this type of services like P2MP and MP2MP. Another aspect is whether or not to build services, slice services over OTN only, or over IP, or over both of the networks. I think it's a matter of operational and a technical choice. It's not, but it's not to say.
Sorry. Are you saying that the operator will try to map point-to-multipoint distribution onto point-to-multipoint connection in OTN?
Well, if it chooses to, yes.
Can you name at least one provider who is doing that?
To support the point-to-multipoint, well, I'm not sure if I know operators doing that. Probably it's better for the operator.
And again, what if IP, which is wider than OTN, okay, uses multiple OTNs and not just OTNs, okay? How do you do point-to-multipoint distribution over multiple transport networks? What I'm saying again, the only way it could make work is that the transport networks provide point-to-point links. That's what it's all limited to. Okay, and using this point-to-point links, then the higher layer can do point-to-multipoint distribution. And one more comment that I forgot. Okay, it's to Daniela and Fatai. Say, if we decide to go with OTN slicing, of course we will have to do the same for all other transport layers, right? For example, there could be no OTNs at all, but you will need to consider slicing in microwave, in OCH, in flexi, in everything. So basically, it opens up the whole slew of pretty much the same work that we've done for topology at tunnels. Okay, now it will be called slicing.
Well, actually, yes, you're right, in the sense that if there will be contributions and the working group will believe that it makes sense, why not? If the working group decides that it makes sense to have OTN slicing, and there are contributions on microwave slicing, and it makes sense, why not doing that?
Yeah, so we spent 10 years basically on tunnels and topologies. Now the next 10 years spent on slicing. Whatever it is.
Personally, there are.
Igor, these comments is exactly the same for the slicing in general, not just for OTN slicing. These comments.
all this conversation between intent and realization. Networking is about one thing, is about delivering from point A to point B, and everything else is a realization. Okay, so you cannot say that we have to decide. The way you define slicing, it basically nothing is not slicing. That's what I'm saying. Pseudo wires are sliced. Everything is slicing becomes. Okay, fiber slicing, fiber layer slicing, all the things could be sliced exactly the same way as you discuss in the OTN context.
Igor, I think I agree with you. So if today all those can be used for the slicing, right? While we are more or less talking about the slicing as a concept, which is a management concept that basically says I am a user and I wanted to have something which we call it a slice. That I can express my needs. I do not need to configure the network myself with all the parameters. I just wanted to have something to say how you meet my requirement.
But 5G is not talking about slicing this way. For 5G, slicing is an emergent process. You understand what does it mean? Emergent, it means dynamic process that tries very hard to make SLOs met. Okay, it is very different from slicing, as you say, like a hard slicing, which is basically carving out resources out of bigger networks.
Well, but slicing.
This is another reason why you do not want to conflate the term slice, because it's totally different what 5G means by slicing.
So first of all, 5G slicing is just one of the use case, right? As the network slice framework already pointed. Second is even
again, Ivan, it is wrong to say that IETF network slicing is not limited to 5G. I disagree with that. It is limited to 5G. It's only you cannot prevent other application to use network slicing, but it is limited to 5G because it doesn't define anything more than what 5G needs.
Igor, this comment you need to report before when we begin to work on the network slicing at the design team, and then to tease. It is not related to the OTN slicing, your comments. It's a general comment about the slicing.
My fault, but okay, I'm late with that. Okay, but imagine that in the tiers, after a while, we do decide that the slicing is limited to 5G and OTN has nothing to do with slicing. Okay, so what will happen with all working CCAMP in all directions, in all layers?
I want as a slide on this, I think.
Okay, let's leave room also to the others. Dhruv is in the queue since a while. Please,
Okay.
Dhruv.
If we can go back to the figure, my question was very much related to what even Danieli was pointing out. And my thinking was coming from what is the relationship between the IETF network slice controller and the OTN slice controller. In the current figure, it totally feels like that the OTN SC is completely independent from IETF NSC. It is not using any of the components that are going to be a part of IETF NSC and something that needs to be rebuilt. But on the other hand, to me, what makes sense is like how we look at the NBI. For the NBI, we are saying that we are just going to augment the IETF NSC NBI with the technology specific, OTN specific elements, and it's sort of like an augmentation. And I think of IETF network slice controller also as an augmentation, in the sense IETF network slice controller does all the operations that we want a slicing controller to do, but it is technology agnostic. OTN SC is just an instantiation of an IETF network slice controller that understands OTN parameters, right? So I think this relationship also we should try to describe. We should not say that OTN SC is kind of completely independent box with no relationship with ITF NSC. If you think about it, this is something also linking to what Danieli was asking, especially in the middle figure. What is the use of, like, OTN SC showing them as an independent body and using this intent like model for this? Because if we think of this as hierarchy of NSC, that is a better way to think of it rather than having an independent OTN SC. That would be my comment.
Yeah, let me try to respond, and then others can follow. So basically, yeah, I think you're right. We have put some description here. So basically, you're right. So in that sense, OTN slice is just an IETF network slice when the IETF network is known to be OTN, right? So if you go back to the to this picture where we show OTN slice, this is essentially an IETF network slice with OTN augments, right? If that makes sense to you.
In a way it does, and I would think that, like, is there really a need for hierarchy in this kind of system? Like, imagine if the top controller understands the OTN specific parameters, then it makes things so much more simpler than, like, having a separate box, need for a separate box, because at the end it's just a software component that we are talking about, which is going to understand the OTN parameters. Of course, if we are talking about, this is totally different network, and you are, like, sending a request to a total different customer or a network, we are not doing that. It's all part of the same network. So having the top IETF NSC understands SC makes so much more sense.
Yes, actually, so those pictures shows what we call the functional block, right? But in deployment or in implementation, you could, if the IETF network slice and OTN slice are put together in a single deployment, that's not a problem. It's just it's just that we let's say to support OTN technology specific slices, there needs to be this functional block in either embedded within the IETF network slice controller or put it as a separate function, which we show it here. Yeah. So
yeah, I think that makes sense. So I think in the document, if we can just say, like, what word you are using for network slice, we can also use the same word for OTN SC. That OTN SC is an IETF network slice controller that understands OTN attributes.
yes, I think we have already recorded the comments to clarify this point in the draft.
Okay, thank you. And I'll not take more of your time so that you can finish rest of your slides.
Okay, let me see if there. So maybe I move forward with the rest of the slides, and then we can continue the discussion. Just to quickly go through that. Okay, where we are at. Okay, the next one is can we call it an OTN slice, right? I think this goes along with our last argument. So basically, the concept of network slicing is originated from 5G, which assumes an IP scenario for with packet transport networks. So what we see here is the TEAS already has made a consensus to redefine the term slicing and applies the IETF network slicing beyond just the 5G end-to-end slicing, right? And as Igor, you believe that it's for 5G only. Probably this question can be addressed to the IETF, to the TEAS network slicing framework. And also we have to point out that in an OTN, there are networks which in which the endpoints of an IETF network slice may not be IP. It may be non-IP, for example, OTN and some other technologies like video, right? So in that sense, when we define the term slice, and then we further clarify that with the term IETF network slice, so if we then call it an OTN slice, which is defined also underneath the IETF network slice framework, we believe that there will be no ambiguity towards the term as long as they are in this scope. So here, then we say OTN slice is just an IETF network slice when the network is OTN. Right? So short answer is yes, we can call it an OTN slice. Okay, so the relationship between OTN slice and layer 1 VPN is, as we already put on the mailing list. So what we understand is the term slicing goes beyond the existing VPN services, right? As also described in the network slice framework. And OTN slice is an intent, and L1 VPN is a possible realization of OTN slice. And of course, we have other realizations also possible. And as far as we understand, some of them have been already implemented. So, and the relationship between layer 1 VPN to OTN slice to layer 1 VPN is analogous to what IETF network slice is towards the L1, L2, L3 VPN, and yeah, which also, for example, enhanced VPN.
Okay, if it's okay with you, I would take the question here because this was one of the topics mostly discussed on the mailing list. I see Igor again in the queue. Igor, you want to ask?
Quick comment. So basically, to say that IETF slice qualification, it's actually something specific to IETF and has nothing to do with 5G is inaccurate. Okay, it is basically, it has everything to do with 5G slice, but this is a way to say that IETF cannot handle things like RAM. Okay, so it cannot be responsible for end-to-end 5G slice. Okay, but it is pertinent to certain component for 5G slice, like core and backhaul. Okay, now the OTN has nothing to do with 5G. Basically, it brings nothing to do, and it's incorrect to compare this way. It is incorrect to basically to do the same qualification by saying that this is OTN slice.
I think, Igor, two things, 2 points. First is about IETF network slice only for 5G, and as again, this question should be going towards the T's. But as far as we see, like the framework already said, it is not just the 5G. There are a lot of use cases that can benefit from IETF network slices, as in the first paragraph of the network slice framework.
It is to say that, for example, this car is not limited to use to Igor, okay? And Daniela can also use this car. Of course, you cannot prevent other applications from using this framework. But the
specific use cases already described in the network slice framework, as we also put in the OTN slice framework.
Right. So
text from
nothing which is defined in the framework goes beyond 5G. So in this way, it is limited to 5G.
I'm not sure about it. Italy, you want to share something?
I say that I quoted the text from the framework in the chat that clearly state that services my benefit but for antennas are include and are not limited to, and the 5G is the first of the list, but the list includes 4 and is not limited to these 4.
Yeah, so and this is basically it's just like to say that IPTV and music distribution can, of course, they can use the same network infrastructure. It doesn't mean that it's only for 5G. But there is nothing in framework that says that these requirements and this concept, this definition comes from application X, not 5G.
It's probably true, like a lot of the requirements are coming from 5G, but again, it's not just the 5G, and probably we should ask this question for Thies to clarify.
You guys take it too literally, okay? You quote a framework like a gospel, like a Bible. It's not Bible.
Okay, but okay, I understand it's a work in progress, right? But again, I think we probably should put comments to the network slice framework to clarify that if that is the way you intend to do. My other comments on your question is you said OTN has nothing to do with 5G, and I disagree. There are 5G services that could run directly over OTN as we see today, right?
I was told by ITU folks that 5G clients will be carried exactly the same way as 4G client.
5G as 4G client. I'm not sure about that. We have a lot of high premium services which runs directly over OTN in order to bear low latency and high quality services for
Of course,
5G.
because IP is actually two-layer layer. Okay, there is a service layer. Okay, and this is a transport layer in IP. Okay, so the transport layer in IP is actually could be replaced by OTN, but the service layer cannot be replaced. So you cannot run anything 5G wise on top of OTN. Because you cannot run, for example, emails and music distribution through OTN without IP.
Yeah, so the at the end is the IP services, right?
Right.
Yeah, but I agree. I agree.
The transport remains the same for 5G and for 4G as far as OTN is concerned.
For 5G, yeah. If you categorize 5G as 5G services, IP services, yes, then it can be transported over OTN, no problem. It can be transported over OTN, over IP, or a hybrid IP and an OTN. Yeah.
What is the 5G service which is purely OTN, in your opinion?
I'm not saying 5G service is purely over OTN. So the type of services that 3GPP.
You said that you disagree when I said that OTN has no particular difference in 5G versus, for example, previous versions, 4G, 3G, whatever, okay? OTN, it is, and in fact, it's no different from any client that uses OTN as a transport.
5G uses... I think someone is trying to respond.
Yes, I think, okay, well, I don't know the details of 5G, but if I understand what Igor is saying, in the 5G scenario, you say that the endpoints of the slice will always be IP endpoints, which is okay, and this is one of the use cases that we are going to support, but we have other scenarios where the endpoints may not be IP. For example, the OTN wholesale or other cases where the endpoints of the slice are non-IP.
What it has to do with 5G then?
Nothing, but it's network slicing has been generalized in this. And there is nothing in this that says that the endpoints must be IP or must be 3GPP, 5G only. So the big problem, Igor, is that you don't agree with what the TIS working group document is saying, and I can understand your argument, but that's not what the TIS working group is saying.
You confuse Itola. This particular argument with Iowa is about 5G. Okay, we are not discussing the framework yet here. Okay, the framework we basically it's something which is work in progress, and it's a big question whether it's about 5G or it goes beyond 5G. This is one of the questions that needs to be decided in TS. With Iowa, all I'm saying is that 5G has zero effect on OTN.
Well, you still have the effect of being able to request to carry 5G over OTN. At least in the control management plane, you need to have something.
Yeah,
properly.
It is something that existed forever. Okay, so for example, the same thing needed in 4G as well. You also need to have OTN service for 4G, and you also need to have some framework that would allow to do like a wholesale OTN and stuff like that, and not just for any application. This is something that existed for 20 years probably.
I think the big problem is that for 4G, the slicing was static and was not dynamic. You don't have an end-to-end slice controller for 4G that has to go and request OTN to set up connectivity. The concept of end-to-end slicing and the concept of transport network slicing is coming from 5G. It's not coming from 4G. And it's a control plane aspect. It's not a data plane aspect.
The reason why it is the interest back to slicing is because previously in 4G, the radio links, they basically have low capacity and the end-to-end quality of service didn't matter much. Okay, now because if you use a microwave for 5G, it puts a lot of pressure to do end-to-end quality of service. And this is why the solution is to go back to network slicing, as far as I understand.
And you disregard the technology that supports better, higher QoS because of that.
And you are not right in saying that when you do 5G end-to-end service, it affects all layers. It actually affects only upper layers, and whatever happening underneath, it's not as dynamic as you described.
That depends on how you manage.
Omyan, please.
Yeah, it looks we're a little bit messy the focus, but I'm trying to clarify that when we talk about 5G slicing, the 5G is a kind of term which is technology agnostic instead of only focus on wireless. So according to the 5G slicing components, it's composed by the run segment, the core segment, and the transport segment. And the IETF network slicing was trying to focus on the transport side, and OTA is a part of that. So we don't have to directly link the OTN or OTN slice to 5G slice, but that is definitely a part in the transport. It can be called domain or some network in the as a 5G slice component. And within the transport network, it's the degree of freedom is dependent on the current operator's choice on the switching from layer 0 to layer 3, which to choose, and is free to combine all the current switching technologies. Of course, OTN is one of the options. That's all I'm trying to say.
Okay.
Okay, do you want to conclude the presentation? We have 1 minute left.
Yeah, so I think I have just one or two. So yeah, the same arguments applies to the abstract topology as we have pointed out. The realization could be done by using T topology for both OTN and for IETF network slice, right? Yeah, I think we can skip that. This, I think we already touched it. It's yeah. I think I have. That's it. The next steps and was trying to update the text and the model and make the alignment between IETF network slice MPI and OTN, and then we goes to clarify and define the technology specific SLOs as pointed in the previous slides. Yeah, I think I'm done with the presentation.
Thanks a lot. So actually, I think this was a good discussion because we had the possibility to elaborate a little bit the comments that were done on the mailing list, but I don't see real meaningful steps forward in the clarification of the issues. Do you think that another hour like this one could be helpful to further discuss issues, or we just try to do that on the mailing list?
I mean, I think we could do both, right? But my my concern is a lot of the comments actually it should probably be clarified in the T's for network slicing first, like the scope of IETF network slice, right? Is it for 5G only or for something else? Is it just the IP or something else, right? With this, if let's say if the IETF network slice decided to say, okay, it should be just the IP only, then OTN slice is out of the question, right? We probably should call it, and also if they say, oh, we do not want to call it a slice, then if we are still trying to put it in a scope, we also should change the names, right? I mean, all those are relevant. I think a lot of the problems are just generic per se, which brought to a lot to OTN slicing.
Okay, good point. Let's do like
Daniele, I think it's a good proposal. Iowa and Daniele, I think that I raised these questions already, but I need you guys to help me with that. I need to actually put some weight and to get the questions because sometimes they're just ignored.
Okay, let's do like this. Let's discuss these questions on the CCAMP mailing list. Once we reach an agreement, we send the mail to the T's as a sort of a liaison from the CCAMP.
Yeah.
What do you think?
Yeah.
Yes, good idea.
Okay, let's do like that. Let's continue the discussion on, or better, let's put together the right questions with the right wording on the CCAMP mailing list. Once we find some sort of agreement and a consolidated set of questions, we send them as a liaison to this. Okay.
Yeah, sounds good.
Great. Thanks a lot. Thanks everyone for participating and for the good discussion.
Thank you. And also, I would encourage everyone to join our weekly discussion on the OTN slicing, just, in addition to the questions we prepare for our T's. Yeah.
Okay. Thank you. Bye.
Bye-bye.
Thank you. Bye.